this video, we're talking about addition and subtraction of like terms. But for this particular example that we're going to be doing, we're also going to need to draw on our knowledge of fractions, common denominator, and negative exponents. So what we've been asked to do is simplify this expression as much as we can. So what we'd like to do is combine all three of these fractions into one fraction. But as you know, in order to do that, we need to find a common denominator among the three fractions. The first thing we want to do to start moving in that direction is to simplify each fraction individually if we can. So we have in this first fraction a couple of negative exponents. We have a to the negative 8 in the numerator. We also have b to the negative 9 in the denominator. Remember that when you have a negative exponent, it has nothing to do with negative numbers. It just tells you to move the value into the denominator if it's in the numerator, or to move it into the numerator if it's in the denominator. So in other words, just switch its place and then the exponent will become positive. So for example here, this a to the negative 8, it's in the numerator. If we move it to the denominator, our exponent will become positive. So we're going to put a to the positive 8 in the denominator, removing this a to the negative 8 in the numerator. This b squared, we already have a positive exponent, so we're going to leave that in the numerator. And our b to the negative 9 in the denominator, we want to get rid of the negative exponent, which we can do by just moving this whole thing to the numerator, and we get now b to the positive 9. We get the opposite of that exponent because we moved it from the denominator to the numerator. In our second fraction here, we have all positive exponents, so we don't need to do any switching. We also can't simplify the b to the 11 and the a to the 8th because they're not like terms. You have to have a common base if you're going to simplify these things. So 4b to the 11 over a to the 8th, we're going to leave that exactly the same. Here for our third fraction, we have no negative exponents, so we don't need to do any switching. However, we have a b to the 11 in the numerator and a b to the 5th in the denominator. These are like terms because they have the same base. They both have a base of b. And when we have two terms, one in the numerator and one in the denominator, and they have the same base, what we do is subtract the exponent in the denominator from the exponent in the numerator. So in other words, this b to the 11 over b to the 5th becomes b to the 11 minus 5. In other words, this 11 minus 5 is the exponent. And the reason that's the case is because b to the 11 in the numerator is like 11 b's multiplied together, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, divided by 5 b's in the denominator. So 1, 2, 3, 4, 5. And what we can do then is cancel 5 b's in the denominator with 5 b's in the numerator. 1, 2, 3, 4, 5. And what we're left with then is just everything that didn't cancel, which is 6 b's in the numerator. And you can see we get the same thing here. 11 minus 5 is 6. So we get b to the 6. Because 11 here is a larger number in the numerator than the 5 in the denominator, we know this b to the 6th is going to be in the numerator. So we have 6b to the 6th divided by a to the 8th. Now before we go ahead and combine our fractions, the only thing left that we can simplify are these b values here in our first fraction. We have b to the 2nd times b to the 9th, which we know is going to be b to the 11th, right? This is the same as b to the 2 plus 9. We add our exponents together, and that's because b squared times b to the 9th, 1, 2, 3, 4, 5, 6, 7, 8, 9, is just like multiplying all 11 b's together. So we get b to the 11th. So cross this out, make it b to the 11th. Now we've simplified our numerators individually as much as we can, and we have a common denominator of a to the 8th. So we're going to put a to the 8th in our denominator, and then we're going to combine our numerators. So we have b to the 11th. We keep our signs in between here. So we have minus 4b to the 11 plus 6b to the 6th. Now we just want to see if we can simplify any like terms from our numerator. And in fact, we can, because we have b to the 11th minus 4b to the 11th. And remember, that's the same as 1 times b to the 11 minus 4b to the 11. In other words, we have one of them and we're subtracting 4 of them. So we're going to end up with negative 3b to the 11 plus 6b to the 6th. And even though b to the 11 and b to the 6th have the same base, they're not like terms because they're added together. We can only simplify them when they have the same base if they're multiplied together or one is divided by the other. when they're added together or subtracted from one another, we can't combine them. So our numerator is simplified, our denominator is a to the 8th, and the only thing we can do to simplify the final answer is, because this is a positive term and this is a negative term, we always like to start with a positive term if we can. So we'll say 6b to the 6th minus 3b to the 11th all over a to the 8th is our final answer when we use like terms to simplify the expression.